The world is a vast place full of mysteries that have puzzled people for centuries. From the first stars to today's astronomers, the quest to understand the universe has led to discoveries and advances. Distant galaxies, exploding stars and Earth-like planets drift through the void of space billions of light-years away. For more than 3 decades, an amazing instrument has allowed us to take a deeper look at these wonders of the universe, the Hubble Space Telescope. Launched in 1990, the Hubble Space Telescope has been peering into the universe, capturing stunning images and revealing the mysteries that have shaped our universe. This article looks at some of the most amazing discoveries made by the Hubble Space Telescope, discoveries that will forever change our understanding of the universe. Prepare to be amazed as you discover the Butterfly Nebula, the Tadpole Galaxy, the Ultra-Deep Field and many other celestial wonders. If you like our space exploration, please support and subscribe to Simply Space and get ready for more amazing videos. The journey of the Hubble Telescope. The journey of the Hubble Space Telescope began on April 24, 1990, when it was launched aboard the Space Shuttle Discovery. However, the road to success is not without problems. Shortly after deployment, researchers discovered a flaw in the main mirror that distorted the images. This failure is a huge blow to NASA and the astronomy community. In December 1993, however, a daring space mission corrected the mirror error, and Hubble returned to the observatory. Over the years, Hubble served many purposes, each time receiving upgrades that extended its life and improved its performance. The telescope's ability to observe in the ultraviolet, visible and near-infrared spectrum is essential in modern astronomy, proving that ground-based telescopes can't match it. Hubble's contribution to science is significant, a window into the past, present and future. The Butterfly Nebula. One of the most spectacular images taken by the Hubble telescope is the Butterfly Nebula, known as NGC 6302. The name, Butterfly Nebula, comes from the symmetrical, wing-like shape of the stardust that resembles a butterfly. At the center of this nebula is a dying star that has shed its outer layers into space, creating complex patterns of gas and dust. A close look at the Butterfly Nebula gives astronomers valuable information about the life cycle of stars, especially the transition from red giant to planetary nebula. The bright colors and complex structures seen in this nebula reveal the chaotic processes that accompany stellar death. In addition to its aesthetic beauty, the Butterfly Nebula reveals the fate of our own Sun, which will also change billions of years from now. The Tadpole Galaxy. The Tadpole Galaxy, or UGC 10214, is a prime example of an interaction and merger. This galaxy is millions of light-years away from Earth, and its elongated tail looks like a frog swimming through space. The tail is the result of a collision with another galaxy, creating a stream of stars and gas. Hubble's image of the Tadpole Galaxy captures its uniqueness, but hundreds of other galaxies are scattered in the background, each with its own history and structure. Studying those interactions is critical to understanding the dynamic nature of galaxies and the forces that shape them. Observations of the Tadpole Galaxy provide clues about the processes that form stars and alter the evolution of galaxies. The shape of the Tadpole Galaxy and the many galaxies behind it show how diverse and complex the universe is. Ultra-Deep Field. One of Hubble's most profound contributions is the Ultra-Deep Field, UDF, image, which represents the deepest field of view in the universe. This image is a collection of several months of observations focused on a small area of space in the constellation Fernax. In this small part of the sky, Hubble reveals thousands of galaxies, some of which are more than 13 billion years old, dating back to the beginning of the universe. The UDF image is a time machine that allows astronomers to study galaxies at different stages of their evolution. A glimpse into the infancy of the universe, shortly after the Big Bang, when the first galaxies and stars formed. The number and diversity of galaxies in the UDF reflects the complexity of the universe's history and the processes that formed the universe over billions of years. This image is a testament to Hubble's unique ability to see the farthest reaches of space and time. Jupiter's northern lights. Closer to home, Hubble has captured stunning images of the northern lights of Jupiter, the planet's largest planet. Auroras occur when charged particles from the Sun collide with the planet's magnetic field and atmosphere, creating a spectacular light Jupiter's auroras are very intense and wide, and smaller than Earth. Hubble's observations of Jupiter's auroras have provided valuable insights into the planet's magnetic environment and its interactions with its moons, such as Europa, Ganymede, and Io. The images reveal the complex dynamics of Jupiter's magnetosphere and the powerful forces at play. By studying Jupiter's auroras, scientists can better understand the mechanisms that drive these phenomena and their implications for other planetary systems. These observations also highlight the interconnectedness of the solar system, where the Sun's activity influences planets and moons in intricate ways. The Eagle Nebula. The Eagle Nebula, also known as M16, is another breathtaking image captured by the Hubble telescope. This nebula is home to the famous pillars of creation, towering columns of gas and dust where new stars are being born. The Eagle Nebula is 6,500 light-years away in the Slangen constellation. These columns are composed of cool atomic hydrogen and dust, and embryonic stars have formed within them. Hubble's image of the Eagle Nebula reveals important details of these columns and star formation processes. The spectacular visual complexity of the Eagle Nebula represents the dynamic and ongoing constellation of stars in the universe. By studying the Eagle Nebula, astronomers can understand the beginnings of stellar evolution and the processes necessary for star formation. The Eagle Nebula is not only amazing, but also a great laboratory for understanding the life cycle of stars. The Spiral Nebula. The Spiral Nebula, or NGC 7293, is called the Eye of God because of its shape. The Helix Nebula, located 650 light-years away in the constellation Aquarius, is one of the closest nebulae to Earth. This represents the final stages of a star similar to our Sun. The central star has shed its outer layers, creating a bright ring of gas and dust. The blue center of the nebula, surrounded by red objects, is very impressive. Hubble images of the Spiral Nebula show plumes of gas created by intense radiation from the central star. These structures, called comet nodes, are illuminated by the star's ultraviolet light. The Spiral Nebula is a glimpse into the future of our own Sun, which will one day shed its outer layers to form the same shape. The study of the Spiral Nebula helps astronomers understand the processes that govern the final stages of stellar evolution and the formation of planetary nebulae. Rat galaxies. The Rat galaxies, NGC 4676, are a pair of interacting galaxies located 300 million light-years away in the Coma Bernic star cluster. Rat galaxies are named for their long tails of stars and rat-shaped gas. These tails are the result of tidal forces when two galaxies collide and merge. Hubble's image of dwarf galaxies captures the massive collision between these world giants and reveals the process of galaxy evolution. Interactions between dwarf galaxies reveal the mechanisms that drive star formation and galaxy evolution. As they continue to merge, they eventually form a single, larger galaxy. Observing these interactions helps astronomers understand the role of galactic mergers in the evolution of galaxies and the formation of new stars and planetary systems. The Mouse galaxies are a living reminder of the dynamic and ever-changing nature of the universe. Protoplanetary disk in the Triad Nebula. The Triad Nebula, M42, is one of the most studied regions of the night sky and a stellar nursery where new stars and planetary systems form. The Orion Nebula, located 1,344 light-years from us, is visible to the naked eye and has been occupied by astronomers for centuries. Hubble images of the Orion Nebula show protoplanetary disks, or proploids, the birthplaces of new planets. These disks of gas and dust around the stars are the material from which planets form. Observations of bulges in the Orion Nebula provide direct evidence to support the theory that planetary systems form from spherical disks. Hubble images show different stages of the disk's development, providing a window into the processes that lead to planet formation. Studying the circular disks in the Orion Nebula is important to understanding the origin of planetary systems, including our own solar system. NGC 1300. The galaxy NGC 1300 is a spiral galaxy located 61 million light-years away in the constellation Eridanus. Hubble's image of NGC 1300 is one of the most detailed images ever taken of a spiral galaxy. The image shows spiral arms, complex dust lines and bright regions of star formation. The central bar structure of NGC 1300 is a prominent feature that extends throughout the galactic core. Detailed observations of NGC 1300 allow astronomers to study the formation and evolution of spiral galaxies, the role of bars in galaxy dynamics, and the processes that drive their formation. Star. The bright colors of the galaxy, along with the placement of blue stars and old yellow stars, show the diversity of stellar populations in the galaxy. The beauty and complexity of NGC 1300 makes it a fascinating subject for both professional and amateur astronomers. Star cluster NGC 602 NGC 602 is a cluster of young stars in the Small Magellanic Cloud, a satellite star in the Milky Way. The Hubble image of NGC 602 provides a fascinating picture of the star's birth and evolution. This cluster is surrounded by a dense cloud of gas and dust from which new stars are born. The bright young stars of NGC 602 pierce the surrounding material with their intense radiation and stellar wind. This process gives birth to new stars, creating a constellation of stars. The image also shows many distant galaxies in the background, creating a stark contrast between the nearby constellation and the distant universe. The study of NGC 602 will help astronomers understand the processes of star formation and the beginning of stellar evolution. The energy and dynamic nature of this constellation has made it an attractive subject for astronomical research. Able 1689, one of the largest known galaxy clusters, Able 1689 is located 2.2 billion light-years away in the Able constellation. The Hubble image from Hubble 1689 is a testament to the massive influence of the galaxy, which acts as a natural lens that magnifies and refracts the light of distant galaxies in the background. This phenomenon, known as a quartz probe, allows astronomers to study galaxies that are very faint or distant. Able's diagram from 1689 shows thousands of galaxies, many of them enlarged and distorted into arcs and rings. This hierarchical lensing effect provides a great insight into the distribution of dark matter in a cluster, as well as the properties of focal galaxies. The Able 1689 image is a powerful tool for understanding the macrostructure of the universe and the role of dark matter in shaping the evolution of the universe. The number of galaxies visible in the image reflects the vastness and richness of the universe. The Cone Nebula, NGC 2264, is a spectacular star-forming region 2,500 light-years away in the constellation series. Hubble's image of the Cone Nebula shows a towering column of gas and dust carved by the radiation and stellar winds of nearby young stars. The cone shape is indicative of dynamical processes occurring in star-forming regions. Ultraviolet light from young stars ionizes the surrounding atmosphere and shines, creating a spectacular visual effect. The cold material in the Cone Nebula is the birthplace of new stars, providing insight into the early stages of star formation. The red color of the nebula is due to the presence of hydrogen gas, which emits light at certain wavelengths. The Cone Nebula's fascinating shape and processes of star formation make it a fascinating subject for visual observation and scientific study.